Today we will solve numerical on vertical curve. This is the first numerical. Along the alignment of road, it is found in a particular portion that a grade of positive 0.5% is followed one of negative 0.7%. The two ends of this portion are to be connected by parabolic vertical curve. The chainage and RL of the intersection point are 550 and 375.50 meter respectively. Calculate the RL of the points on the curve taking peg interval of 20 meter. The rate of change of grade is 0.1% per 20 meter. Okay, this is the question basically on summit curve. See here, this is the grade percentage. First grade is positive, that means increasing, and second one is negative grade, that is decreasing height. Okay, so that is, this curve is summit curve. First write down the given data. So given data is this is the profile. Okay, this is the summit curve, this is the grade. Upgrade is 0.5% positive, that means increasing. Okay, and decreasing grade is minus 0.7%, that means decreasing. Okay, so starting point is A, summit point is B, end of the curve is at C point. Okay, here chainage and RL of the, now see here, the chainage and RL of the intersection point 550 and 375. 550 and 375 is given to us. That means this is the intersection point. B is the intersection point or summit point or apex point. Okay. A is the starting point. C is the ending point. First design step is, this is also very important point, the rate of change of grade is 0.1% per 20 meter. Okay, this is not the peg interval, this is 0.1% per 20 meter. Now length of vertical, this is the first design step. Length of vertical curve is equal to grade 1 minus grade 2, that is G1 minus G2 divided by R. R is the rate of change of grade per 20 meter. Okay, so G1 we know the positive, that is 0.5% minus, and G2 is negative 0.7% divided by rate of change of grade is 0.1 for 20 meter. Okay, that's why multiply by 20 is equal to, the length of vertical curve is 240 meter. Okay, length of curve on either side of the apex is 240 by 2 is equal to 120 meter. That means this is the total length of the curve is 240 meter, and half curve is here, half curve is here. So this distance is 120 meter, this distance is 120 meter. Equally, this length AB is 120 meter because we consider the length of curve and grade is same. We assume the length of curve and length of grade is same. So this is 120 meter, this is also 120 meter. Now chainage of A. Okay, chainage of A, that means this chainage of this A. Chainage of B is given to us. Chainage of B and RL of B is given to us. Now we have to calculate chainage of A. The chainage of A is equal to chainage of B minus half length of curve. So chainage of B is 550 meter minus half length of curve is 120 meter, because half length of curve and half length of grade is the same. So this is also 120, this is also 120. Okay, that's why chainage of A is 550 minus 120 is equal to 430 meter. So just we got the chainage of A. Now chainage of C. Now we have to calculate chainage of C. That means this chainage. The chainage of C is equal to chainage of A plus length of curve. Chainage of A is 430 meter and length of curve is 240 meter. So we just got chainage of C 670 meter. Okay. After that we have to calculate RL of A. Okay, after that we have to calculate RL of A. That means this A point, we have to calculate RL of this A point. Okay, but in the question we have given the RL of B. Okay, in the question we have given the RL of B, that is 375.50. Now we have given the RL of B and we have to calculate RL of A. In between this is the grade. Okay, so this RL of B is higher than RL of A, so we have to minus this grade. So RL of A is equal to RL of B minus, now percentage of grade is 0.5% and length of the grade is 120 meter. Okay, the percentage of grade is 0.5% and length of the grade is 120 meter. So we have to minus this grade. So RL of B minus grade is 0.5%, that's why 0.5 divided by 100, and the length of grade is 120 meter is equal to 374.90 meter. RL of A is 374.90 meter. Now we have to calculate RL of C. We have to calculate RL of C. So again RL of B minus this grade into length of the grade. So the grade percentage is 0.7%. Again here RL of C is equal to RL of B minus the grade is 0.7%, that much 0.7 divided by 100 into length of the grade is 120 meter. So RL of C is 374.66 meter. Now we have to calculate RL of E, that means this E. We have to calculate RL of E. For this purpose we have to take the average of RL of A plus RL of C. So average, that means 1 by 2 into RL of A. RL of A is 374.90 plus RL of C is 374.66 is equal to 374.78 meter. Okay, now RL of F. In order to calculate RL of F, we have to take average of RL of B plus RL of E. Okay, we know that RL of B is 375.5 and RL of E just we have calculated 374.78. So we have taken the average of this and we just got the RL of F is equal to 375.14 meter. Now tangent correction at apex. This is the apex point. Okay, this is the apex point and the apex point is at B. Okay, and RL of B is 375.5 minus RL of F is 375.14. So this distance is 0.36. This distance is 0.36. Okay, so this is the apex tangent correction at apex. Now we have to calculate tangent correction for all points. Okay, we have to calculate tangent correction for all the points. Tangent correction for points at 20 meter interval, because chainage is 20 meter. Here we have to consider the chainage. Okay, that means peg interval. Here we have to consider the peg interval, that is 20 meter. So formula for tangent correction is grade 1 minus grade 2, that is G1 minus G2 divided by 400 is the constant and length is the half length of the curve and X is the peg interval. Okay, so tangent correction for first point is, first grade is 0.5 minus second grade is minus 0.7 divided by 400 into half length of curve is 120 and peg interval is 20 meter. So 20 square. So tangent correction for first point is 0.01 meter. Okay, after that we have to calculate tangent correction for second point. Again the same formula, only this interval will increase by 20. Okay, so previous case 20 meter, then 40, then 60, then 80, 100 and 120 till the check, because this is the check 0.36 meter. till we have to calculate this number of corrections. Okay, so we got 6 points in order to calculate this number of correction on tangent. Okay, so this is point 1 2 3 4 5 and this is the 6th point. Okay, this is the apex point. Just we have calculated 0.36 and this correction is also 0.36 meter. So this is check here. After calculating tangent correction, we have to calculate RL on the points on the grade. Okay, we have to calculate RLs on the point of the grade. RL of the points on the grade left hand side curve. Okay, now we are considering this left side curve, then we will consider right side curve. First we are considering left side curve. So again the formula, because on left side the grade is 0.5%. okay, grade is 0.5%. so rise, this grade is rising. Okay, so rise per 20 meter, and for 0.5% that is 0.5 by 100 into 20, because rise is per 20 meter. Okay, so correction, that is 0.10 meter. Okay, so RL of first point on a grade is equal to RL of A plus this correction 0.10. Okay, so RL of point on a grade, that is first point is this point. Okay, first point is this point. We have to calculate this point. Okay, so RL of A is 374.9 plus 0.1. We have already calculated RL of A, and this is the addition 0.1. So this is 375 meter. RL of first point on a grade. Then RL of second point on a grade is, take previous value 375 plus 0.1, that is 375.10 meter. Now RL of third point on a grade, 375.10 plus 0.10. Add the 0.1 to previous value. Okay, so RL of 6 point on a grade, that is 375.4 plus 0.10 is equal to 375.50. We know that 375.50 is RL of B. That means this point. Okay, which is already given and we have calculated again. So that is the check. Okay, so the 6th point is the B point or apex point. The RL of the point on the grade right hand side, just we have to calculate on left hand side. Now we have to calculate right hand side, because grade here is 0.5% and grade here is 0.7%. so we have to calculate this grade also. Again same formula we have to use. 0.7% that means 0.7 by 100 into 20. 20 is the peg interval, is equal to, this correction is 0.14 meter. Now here we have to subtract 0.14 meter from all the points, because this grade is going downward. Here we have added 0.1% because this grade is going upward. The RL of the 5th point on grade, we have to start from decreasing order, that means from here. So 5 4 3 2 1. Okay, so first point is 5 dash, that is RL of the 5th point on a grade is equal to RL of B minus 0.14. so this is the constant, minus 0.14. We have just calculated with the help of grade percentage. So RL of B is 375.5 minus 0.14. Why minus? Because this grade is going downward, that's why minus. Here we have added that constant because this grade is going upward. Then 4th point on grade, take this value here, minus, again this constant is 0.14, again take this value here, minus 0.14 till the point C. Okay, so C point is RL of point C is equal to 374.80 minus 0.14, that is 374.66. That is 374.66. This is the check. We have here also calculated RL of C is equal to 374.66. Okay. So till RL of C we have to calculate the RL of points on a grade. Okay. After this, next step is RL of the point on the curve. Okay. First we have to calculate RL on the grade, then RL on the curve. Okay. RL of the point on the curve. First we consider the left hand side curve. Okay. The RL of the first point on the curve is equal to, now see here, we have to, for this purpose we have to consider RL on the grade plus tangent correction. RL on the first point on a grade is 375 minus this tangent correction. Okay, tangent correction is for first point is 0.01. okay, so here is 0.01. then RL of the second point of the curve is, again, second point on the grade is 75.10. so 75.10, and tangent correction for second point is 0.04. third point is 0.09, 0.16, 0.25, 0.36. so these are the tangent correction which we have to apply on these points. So RL of the second point on the curve is 375.10 minus 0.04. RL of the third point on the curve is 375.20. So 375.20, then 375.30, 375.40, and last one is 375.50. Okay, so 375.50 minus 0.36 is equal to 375.14 meter. This is the RL of F. Okay, this is the RL of F, which is here. So this is the last point on the curve. The curve is assumed to be symmetric, and so the tangent correction for the right side exactly same as for the left side. So we have just calculated RL of this curve. Now same is the RL is for this curve also. Okay, now this is the table. In this table we can see that our starting point is A and ending point is C. Okay, chainage of A is 430 meter, then chainage of second point is 450 meter, chainage of A is 430 meter, first point is 450, then 70, because we have an interval of 20 meter. Okay, this 6 point is the apex point or B point, then decreasing order, that is 5 dash, 4 dash, 3 dash, 2 dash and 1 dash, and this is the 6C point. Chainage of C is 670 meter. The grade of RL is, for first point, A point is 374.90 and 37. So here is the 374.90, then 375. This is the RL of point on a grade. So this is the values for grade point: 375.10, 375.20, 375.30, 375.40. So these are the values. And tangent correction. Tangent correction is 0.1, 0.4, 0.9, 0.16, 0.25, 0.36. And then again after that same value will be repeat here, because the table curve is the same. Okay, the curve is half curve is the same. Thank you.